Okay, now that you've gone through how to do the calculations, you have a general idea, I'm going to show you some example questions for accumulated degree days. These are the types of questions that you're going to be seeing on your quiz, the types of questions that you're going to have to be answering for your assignments. So I'm going to walk you through how to do them. Just know that you're going to be doing this with slightly different species. All the stuff will be given to you. So let's walk through a few questions. Okay, so I'm going to use Chrysomya megacephala as an example. In the problems, you are given life tables, the threshold, and the temperature data. So you'll probably be using Macellary or something. Whatever life tables I give you, just read the questions. So let's start with a first example question. Step 1. The way that I like doing these is I like walking you through your the basic steps that you've seen me do over and over and over again in all these lectures. So first question, how many degree days are necessary for Chrysomya megacephala to go through each of its life stages? So remember, that's what we've done several times. And I'm specifically asking for degree days here. So the key to some of these questions is to read the question. So degree days. So remember, these are hours, temperatures, etc. So what we need to do there is we need to fill in our table. So in this case, just like we did before, we got the eggs. I've turned them into days by dividing by 24. So now we got the degree days. And then we go through our formula, average temperature minus the threshold times the unit of time. So our average temperature, 21 degrees Celsius. Threshold, 6 degrees Celsius. Unit of time is our days. Average temperature minus threshold times the unit of time. We get a table that looks like this. So for each egg stage, you get 6.3 degree days, 7.5 degree days, etc., etc. So if I were to ask how many degree days are necessarily to go through each individual life stage, these are the answers you're looking for. So this is just a way for me to get you to start filling out your table. Second question, how many degree days are necessary for Chrysomya megacephala to go through its entire life cycle? So from egg to the end of the pupae. So think about that life cycle, right? It needs to lay the eggs, go to first instar through the second, through the third, through the fourth, through the fifth. Fifth instar. Okay, through the fifth stage. That's the pupal stage. So how do we figure that out? We just add them all up. So we've done this before. So then in this case, it's 6.3 plus 7.5, 13.8, 28.2, 22.5, and 61.2. We add that up. So that answer then is they need 139.5 degree days to go from the beginning of the egg stage to the end of the pupal stage. That's what we know. Now notice I put degree days at the end, right? Always put your units, okay? If you don't, then I'm going to have no clue what you're telling me. And let me tell you, in a few days, you will try to look back on your work and you'll be, what the hell was I calculating? Son of a. Always put your units. So degree days. If you're doing degree hours, it's DH. Done. Okay. So pretty straightforward so far, right? Just average temperature minus threshold times the unit of time. I'm going to be saying that until you want to punch me in the face. Next question. All right, so our next question using the same stuff. So now we've got our table. We know how many degree days it takes to go through. You find Chrysomya megacephala eggs on a body. Okay, so this is how I want you to walk through these things. Remember back to when you were doing word problems in grade school and you had to underline stuff. I don't know if you did that, but whatever. Okay, so Chrysomya megacephala, great. That's the species we're looking at. We've already calculated how many degree days are necessarily for each stage and what the total degree days are to the end of the pupal stage. You find eggs. Okay, so we're looking at this stage. Great. Now, a body was kept at a standard temperature of 27 degrees Celsius. So standard temperature at 27 degrees Celsius. Now, the question is, how long has the body been there according to the insect evidence? So now my data, my life table, from where the flies were reared at 21 degrees Celsius, right? So that is the data. So 21 is, what is that, higher or lower than 27? It's lower. So therefore, I now need to take these degree days from my life table and figure out how long it will take to accumulate this number of degree days at a higher temperature. Remember, back to our basic money examples, the more money you get paid, the faster it is you're going to be able to save up for stuff. In this case, the warmer it is outside, the faster they're going to accumulate the degree days. So let's go from here. What this question is actually saying, you've got a house, body was found inside, okay? So this body was found, kept at a standard temperature, 27 degrees. Most commonly that happens indoor house. Chrysomya megacephala came in, laid eggs on that body. You found eggs. You know it was kept at 27 degrees Celsius. Beautiful Nest thermostat, tells you perfect, okay? Now I need to know how long has that body been available for colonization, given this information. So the way that we do this, we use our average temperature minus the threshold times the unit of time. So we have to say how many degree days do we accumulate each day in that room at 27 degrees Celsius. So in this case, you don't need to go to NOAA and find the weather. You don't need to do anything. It was indoors. The thermostat was set at 27 degrees. This is the easiest time or the easiest weather data that you'll ever have to pull, because it's already there. So we just do our normal calculations. We take 27 degrees, average temperature, minus the threshold. Remember, the threshold is always the threshold for the insect that you're using, minus 6 times 1 day. So we have found that each day, the indoors, it accumulates 21 degree days. Now, we only need 6.3 degree days for the eggs to hatch. So we know it took under a full day. So that body has only been there a day or less, because 6.3 is way under 21. Now, we can get more specific if we use degree hours instead of degree days. Okay? So each day in that room, we accumulate 21, or each hour in that room, we accumulate 21 degree hours. So we can be a little bit more specific, but each day in that room is 21 degree days. Now, degree hours, let's say instead of doing degree hours, or degree days, we want to do degree hours. So we just go through average temperature minus threshold times the unit of time. We figure out a degree hours. We're using hours instead of days here. This is what we need. Okay. Now we can do the exact same calculations, except we're changing the unit of time. So let's say, how many degree hours do we accumulate each hour in that room at 27 degrees? Our same formula, average temperature, 21 degrees or 27 degrees Celsius minus threshold, 6 times the unit of time. In that case, it'll be 1 hour. So 27 minus 6 times 1 equals 21 degree hours. So each hour in that room, we accumulate 21 degree hours. So try to figure this out. You could either count by 21 in the first hour, 21 in the second hour, etc., or just divide by 150. Okay, 0 to 150 degree days for that hour, you get 7.14 hours. Now remember what we're asking here. How long has the body been there based on the insect evidence? Whenever I ask this question, think of me as a cop. You need to give me an answer that I will understand as a cop. So if a body died and the fly showed up within 15 seconds of death, then the age of the eggs should equal how old the body is. Since we know that the eggs are somewhere between 0 and 7.14 hours old based on our calculations, then the answer to that question would be 0 to 7.14 hours. Notice that I put hours. Remember, you will lose points if you don't give me the units. Otherwise, I don't know what you're talking about. So we have our 7.14 hours. Hey, there we go. Okay, so you see how I did that? So we have 150 degree hours are necessary for the stage. We divide it by the number of degree days or degree hours that happen each hour, and that turns it back into hours. So degree hours necessary divided by degree hours represented, bam, gives us our hours. So then a cop can come to me and say, how long has this body been here? It's been here either between 0 hours or 7.14 hours. So, you probably round up to 8 hours. Died somewhere between there. Done. See how straightforward that is? Okay. So now we can do this exact same calculation with any one of these stages. We just need to come up with the correct range. So remember how we did the ranges? We add things up. So you have a bunch of questions like this on your next assignment. So what's going to happen? It's going to say things like, you find a first instar larvae on a body that was kept at a standard temperature of 27 degrees Celsius. How long has that body been there, given the insect evidence? Or you find second instar, or you find third instar. All you have to do is figure out the range and translate that into hours or days. Now, when you give your answer, just choose which time period, hours or days, makes the most sense. So if I said to you, say, something happened 24 hours ago, you know I mean one day, right? Yeah, I mean, 24 hours, that's a pretty common thing. Same thing with 48 hours. Everybody knows that's 2 days. But what if I told you something happened 384 hours ago? How many days is that? That's not nearly as clear, right? That's not as easy to automatically translate into days. So in this case, I want to say something happened 16 days ago instead. Just use your brain on this. Okay, so if you were talking to somebody who didn't do all this calculation, what would be the easiest, most clear way to communicate this information? Days or hours? Either way, it's up to you, but you have to be able to communicate the information clearly. Okay, so let's work one more problem like this. You find third instar Chrysomya megacephala maggots on a body. It was kept at a standard temperature of 27 degrees. How long has that body been there based on the insect evidence? So we're going to do this exact same thing like we did before. Okay, so we've got our degree days up here, our degree hours down here. Done. Now, we want to figure out then how many degree hours or degree days it's going to take to get to the end of the second instar, which is the beginning of the third, and the end of the third instar. Now, how do I know that's the range I'm looking for? That's what I found on the body. So third instar maggots. So when you find third instar maggots, you have to go to the end of the stage before and then the end of this listed stage. So in this case, the end of the second, end of the third. You're looking for that range. So all the way up to the end of this, to the end of there. So we'll figure it out. So again, we just add things together. Let's say I want to use degree hours. Seems straightforward. So in this case, I'm going to add up 150 degree hours to account for the egg stage, 180 to account for the first instar, and 330 to account for the second. So that's all the way to the end of the second instar, as if I just walked in on this body and they just eclosed into the third instar. So it takes 660 degree hours to make it to the end of the second instar. And then I do the same thing to figure out the third, 150 plus 180 plus 330 plus 675. So in that case, it takes 1,335 degree hours to the end of the third. So what this gives me then is now my range in degree hours. So this is 660 to 1,335 degree hours are necessary to have that maggot in the instar where we observed it on the body. So somewhere between there. If there were fewer than 660, we wouldn't have seen third instar. If there were more than 1335, we wouldn't have seen third instar. Would have gone into prepupal. So that's what we're doing here. Okay, this is our range. Now, we know that 21 degree hours accumulate per hour in this room. So we do that with the average temperature. It's 27 degrees minus threshold. That's given 6 times 1 hour, 21 hours per hour. So again, we can just count by 21, right? Just how many hours is it going to take to reach our minimum of 660 and our max of 1335? Okay. The question is then, how many hours do we need to reach this? So let's divide by 21. We know it's per hour. So it's going to take 31.43 hours to reach the end of the second instar. Pretty straightforward. Now, the max then is 13.35 divided by 21, 63.57 hours. So this body has been available for colonization somewhere between 31.43 and 63.57 hours. Now, so that's just, over a day, not quite 3 days. It might make a little bit more sense if you decide to put it into days. You can do that just by dividing by 24. You can do that if you want. Doesn't matter, but it's pretty straightforward here. If you want to do it in days, it's 1.37 to 2.65 days. So that's what we're looking for. And notice that I've got my units every time, so I know what I'm talking about. Hours, degree hours, days, degree days. But this is the answer I'm looking for. So if a cop came up and said, okay, we found third star, chrysomyomega maggots on this body. How long has that person been there? You can say, based on these calculations, somewhere just over a day to just over 2 days. There you go. All right. So that's the basics of some of these questions. In the next lesson, I'll go over a few more. Let me know if you have any questions.